Welcome to our webinar discussing Sentinel Graph, and thank you all for investing the time to attend. We're really excited to have you here and talk about the Graph released features. So to give you a bit of the agenda, we'll start by covering Sentinel's journey and providing some background on graphs, why we think they're so awesome and valuable, and show you some demos. And lastly, we leave a bit of time, hopefully, to cover some of the questions. So I'm Shirley Kochavi, and we have here with me Sourin, Paul, who'll be co-hosting. We're both product managers in Sentinel Graph team. We have our great supporting team to help us answer all questions and cover everything that you drop in the chat, so feel free, ask, and they'll be happily reply. And with that, let's get started. So a little time traveling to get us started here. Microsoft has been on a journey to modernize the SOC to defend against the evolving threat landscape. So we started off with the launch of Sentinel back in 2019. And ever since then, we've constantly involved bringing SAR and UEBI and TP into the SIEM, continuously expanding our connectors gallery, and we've reached more than 350 connectors to this time. Alongside all of those development, we are also bringing and integrating the Defender XDR in cloud security and exposure management, and eventually also bringing in generative AI, unifying everything into a truly unified and extensive SecOps platform. You probably know this as the security or the Defender portal. And by the way, we're proud to share that we've earned the share and the trust of over 2,500 customers worldwide. So now what? We've evolved Sentinel to be more than a SIEM. Sentinel is now a platform. Our cloud security and XDR tools centralizing signals, offering a single pane of glass to defend your environment from attacks, helping your team implement the right controls to protect your cloud infrastructure and end user environments. And what happens when an incident does happen? Well, we have automatic attack disruption that will dynamically contain the compromised assets, stopping the attacker and minimizing the blast radius. And that's all powered by Graph. And Security Copilot is also here with every step of the way and helping you reclaim hours of accelerating detection and response. So graphs. Attackers don't view your environment as isolated systems. They see relationships. They think how they can propagate within your network. They map out how identities connect to devices. They map out the permissions and resources and how they connect, how they communicate. They think how all of those connect and how they can exploit those connections. And they move laterally, escalate privileges. They're targeting one of your assets there. There is a known phrase, you probably heard it if you're following John Lambert's. Defenders think in lists, attackers think in graph. As long as this is true, attackers win. And for a long time, defenders have been limited to querying and analyzing data in tables. We've forced you to know well your KQL and think in silo or write very lengthy and complex joins over joins over joins around those tables. And meanwhile, attackers gain control and access into your organization and move laterally, evading defenders. So we listened and we started connecting the dots ourselves, building graphs to help defenders. So quick intro on what graphs are. You might have already gotten the idea. A graph is just a way to present relationships. You may recall it from your geometry classes back in school, points and lines that represent relationships between variables that are used to illustrate shapes or trends, maybe intersections and areas. We're taking those ideas and bringing them into the cybersecurity world. Graphs are now referring to network of nodes and edges. So what does it mean and how do you know what's going to be modeled as part of that? That's going to be the ontology. So we're dropping a bit of terminology here. Ontology is actually how you map those nodes and edges. So a node can actually be users or devices. It could be files. It could be IPs. It could be even something like a MITRE framework or techniques. Edges can be representations of permissions or activities, network connections, network traffic, logins, file transfers, steps that were taken advantage by an attacker. It's really up to you what those nodes and edges are going to represent. A bit more on the terminology here. Hoops are nodes along a path, and path or traversal are the edges that compound the journey. For example, mentioning asset exposure attack path would explore an internet exposed device in the organization network. And if that is penetrated, the attacker can actually move laterally towards a defined critical asset. Attack graphs model how adversaries pivot through systems using credentials or dependencies and misconfigurations. We get the data in the lake. We get the data from all of the defenders that are connected to your environment. And all of those are reported through the Defender products, and we can oversee now everything. And that grants us the opportunity to present the pre-breach map as well as the post-breach and the blend of them both. So time to talk about the already released experiences that we have in both portals. So we started the graph journey in both Defender as well as Purview portals. Both were released at 9:30. We'll review some of the graphs we provide out of the box as integrated experiences that are all generally available for all the Sentinel Lake customers. Starting out, we're going to talk about the blast radius. This is really where the magic happens. Because when you're in the middle of an incident investigation, the hardest part is not going to be finding yet another alert. It's going to be figuring out where the attacker can actually reach next. That's what the blast radius graph inside the incident graph is for. It's going to take the entity you're investigating, may it be a user or a device, maybe some other compromised node, and then it's going to evaluate and visualize the vulnerable paths the attacker can take from that compromise to more valuable targets. You can stop guessing and start prioritizing and decide how you're going to react to that incident based on those propagation paths. Instead of scrolling through disconnected evidence, you can see the routes that matter, the relationships, the hubs, and those will explain how a foothold can turn into real impact. And that clearly is what helps you decide where to contain or harden first when time is right. Bringing together those insights from what is known as the pre-breach data with what we know as a post-breach knowledge merged in a single visualization is the actual power of a blast radius graph. So here we have this incident that I've noticed in my queue as a SOC analyst. I see that it has an exfiltration incident on one endpoint. So I'm looking at it and it looks to be like a DLP related incident. And I'm going to review all the alerts here, scrolling back to understand how it propagated and what happened. And once I'm ready, I'm going to check the nodes here. And I see the user and the device. So I'm interested in knowing what else can be reached from this device. I'm going to click on the node. And once I have the option, I'll click on View Attack Radius. So as it moves to the left and gets me that loading sign, I know that it's going to show me a path. And sure enough, we have here. We can see a path clearly passing through this cookie that is belong to Sam. And Sam is actually going to grant me the permissions to reach 4 different key vaults. I can also see here which exactly key vaults there is, and if needed, I can extract all of those and see them as separate paths. You can also move the nodes and check those out as you need. Once I'm ready and I've finished exploring all that needs to be explored, I can hide this and get back to my investigation. Sorry, give me just a second. Our next graph will review the hunting graph. The hunting is designed for proactive analyst-driven exploration. You're going to start with a question or an hypothesis, maybe an entity, maybe a technique, and the graph can visualize the relationships so you can trace paths, spot potential choke points, and surface connections that are easy to miss. It lives in advanced hunting in the Microsoft Defender portal, and it's built to get you moving quickly back and forth between table exploration and the graph views. You can start from an empty blank canvas. Something like an entity connections will get you a very nice starting point that you just explore around, or you can start from one of our predefined scenarios. Once you're ready, you can also click the plus sign, we'll show you just in a second, and then explore around and see other connections that one of the entities is going to show. So if we use the exposure graph for what does my environment look like, this one is going to feel more or answer more about what's the story behind the lead. What should I pivot to next? What query do I need to extract out of the tables? And it's located so that it's easy to move back and forth between the queries. So here I have my advanced hunting screen. You can see that the queries are just here. And if I want to use the graph, I just click on that, open a new tab, and then here I can search with the predefined scenarios. So let's say I want to explore that machine that we've seen before in the incident. I'm going to pick the scenarios of the entity connections, just to explore around and see the immediate connections or first degree hops that we have here. So the machine was Win 11, and that will help me and find that machine that I've seen before by suggesting some other machines I can put in. You have built-in filters here that you can use. You can adjust or you can leave them as is. Each scenario is going to have its own relevant filters. Once I hit the run button, it's going to explore around the graph, and then once it's ready, it's going to present a picture here. So in this case, we can see that this machine has a CVE for it, and we can continue exploration from this. Maybe I want to know what else Sam is connected to. So I'm going to click on the plus button, and then all of Sam's connections are going to be presented for me as well. And I can continue and explore more and more from here until I'm ready to either disprove an hypothesis I started out, or just continue to explore, or maybe prove it and take some action. Sorry. And now we talk a bit about our most veteran graph experiences that we released back before even Sentinel became a platform. So we've had the exposure map graph out there in GA for quite some time. And sometimes it may be referred to as the attack surface map as well. It's a way to visualize your environment and to see what's connected to what. You can also see the attack paths as they're shown here. It's going to show you not just separate list of devices, users, and cloud racers. It's more of a living network of nodes representing assets, identities, and workloads. And those are connected by the edges that represent the relationships between those. Specifically targeting attack paths from external exposed devices to your critical defined targets. This is what you actually see here in this photo that you see in front of you. So you can get a sense of what can reach what. And you can start from something concrete, again, an internet-facing VM or a privileged identity, or maybe a sensitive data store, and then quickly trace the paths around it to understand likely routes from an internet-exposed entity and where they can end up with the targets. And that's a real value. It's going to take abstract exposure and make it a navigable map. It's going to help you spot risky connections, and then you can actually take some actions against it and solve those cases. So next two graphs we're gonna talk about are the ones to the right here. Those belong to the Purview portal, and this would only be just a glimpse to give you a taste of what we released there, and we will not be talking or demoing what we have. We're going to have a dedicated session or webinar for Purview and the releases, and part of it is going to be the graphs, so definitely check that out. It's coming in March. You can sign up for that. So again, quickly going over what we have there in Insider Risk Management Solution, the top one. We have a data risk graph that is giving you the show me the story kind of a view. It's a visual investigation that pulls in asset context and user activity into one place and then summarizes the alert related trail for the user covering the last 30 days or so. And that can help you really triage the evidence instead of stitching together scattered breadcrumbs along the portal. This view is naturally powered by Microsoft Sentinel integration, and it helps spot the connections that matter. So for example, if we have a user that downloaded a file and then maybe renamed it and created or shared it over SharePoint, instead of hopping between the views and trying to stitch the context, you can actually follow the connections on the screen and quickly decide whether this is an routine behavior and you're okay with it, or this belongs in the true escalation and needs to be reviewed next. Next one is the data security investigation. That has recently been announced as general availability, so check it out if you haven't so far. That's a great solution. And here you can create an investigation that is trying to see what data is exposed and who can access that data. The DSI one, the data risk graph view, is actually making the case real. So once you've scoped in an investigation to specific items, you can jump into the Explore Insight button there and get a visual map that actually correlates the impacted data, where they travel to, who the users that have interacted with it, and all of the activities that were actually occurring to those files. This is summarizing the previous 30 days of activity for any file in scope. So you can quickly see who downloaded it or interacted with it, who renamed it, whether it was accessed from a risky IP, and what sequence of actions actually led up to that incident, often surfacing additional users or contact that you need to pull in and out of the investigation, and enables you to explore even further. So you have a little barcode there on the right side. Definitely check that out. It's going to lead you to our learn.microsoft documentation site where you can read more about all of these. So we talked a bit about the graph and the releases, and all the portal experiences that we have. And it's the era of AI, right? So we can't really have a webinar without mentioning AI or talking about the MCP tools in it. So we'll start by providing a quick introduction to the concept, just in case somehow it slipped through your social media feeds or anything of the past year. And then we mention what exactly we have for the graph. So starting out with what MCP is. That's the initials of the Model Context Protocol. And that's a very simple idea to get you started, and it brings a big payoff with it. It's an open protocol, client-server based, that standardizes how AI agent actually discover and use external data and capability as tools. So instead of every agent actually needing to be the special agent or the bespoke integration for every system, it's going to discover the server, the MCP that exposes the context in a consistent way, which is actually those tools that we're going to talk about. And that's going to be a very clear description, natural language, input, output for you to explore. So an MCP client, or usually an agent framework or an IDE extension, can find the right tool and invoke it while it works. In Sentinel, the MCP server turns your data lake context into reusable tools so agents can work with your security data without you first teaching them every schema. The goal is practical. It's going to give the models and agents access to your real security context and make tool discoverability or selection predictable. So now we're taking that one step further into the graph. We've added the graph analyzer tool collection in Sentinel MCP server, and that's going to let you to reason over the multiple offered Sentinel graphs using natural language. So you can ask the kind of questions that you would actually explore without really knowing how to perfect KQL or GQL queries, and you'll get your answers back. So packaging this into a purpose-built Sentinel MCP tool, it's going to include the blast radius, the path discovery, and the exposure parameter. Your agent can answer questions like, what is the blast radius from Jane Smith? Is there a path between user X and key vault Y? Is there a path between two specific users? You can ask all of those in your natural language, plain language. You don't have to go into the details there. The tool collection makes the graph speak your language. So teams can start with a question like, who can reach the domain controller? What's exposed? What shows the vulnerability, CVE, and give it the number? What's the likely impact if a service account is compromised? Or show me all the entities within 3 hops from this suspicious IP. And immediately get a graph reasoning back, fast enough to actually use it, even when you're juggling through while handling other fires because you have incidents. You can use the answers to help you prioritize what to harden, what to patch, where to respond, where to seek the next threat. And this is a very exciting tool to help craft those insights from the agent. So you have a barcode there below or to the right side. You please scan it and sign up for the preview. And please, 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 once you do that, please share your feedback with us. We really value your opinion and would love to hear your thoughts or your experience and how would you use it and what else would you add. So this is a glimpse of how it looks when you actually ask it. So here I asked for the blast radius of Joseph Ran, which is a user in my environment, and you can see it ran and provided me with the answer here. So you may have gotten to this point and you're wondering to yourself, well, that's all nice, but what if I have my own idea of ontology that is tailored to my own scenarios? what if I have my own idea that is tailored to my environment? It uses third-party data and not Defender's data. Well, we have you covered. We know security teams have their own unique security scenarios that they want to actually enable and visualize. And that's why we've announced the custom graphs in Sentinel. And that's going to let you create and analyze graphs tailored to the data that you care about most. So just before dropping in there, we're going to talk a little bit about what custom graphs are. So that's the way that custom or Sentinel stops handling your own pre-built pictures and lets you draw the picture your own. That's going to match your environment. So instead of being limited to whatever Microsoft decided to model, you can define your own nodes. You can define your own edges from a table that you already have or the data that you've already streamed into a Sentinel Lake. Then you can build a graph to answer the specific questions that your team actually asks or cares about. Custom graphs have the ability to create other ad hoc graphs for one-time investigation that require quick pattern examination, or if desired, you can create custom graphs persisted and maintained. So two flavors of custom graphs, as mentioned before. They're meant for different rhythms of work. So ephemeral custom graphs are built it, answer a question, throw it away graphs. That's great for a fast investigation spike when you don't want to commit to maintaining anything for a long term. This is your ad hoc, use it and lose it kind of a graph. The notion would fit a scenario in which you're hunting anomalies in sign-in logs, for instance, and want to visualize the sign-ins with IPs. And that's going to enable you to quickly spot a weird pattern. But what happens if you want to persist your graphs? Then that's going to be a materialized custom graph. They're the opposite. You persist them. You can update them over time. And this is something that you want when the graph itself becomes a recurring asset. A great example in this domain would probably be ongoing identity or access path analysis. And that's going to track privilege relationships and how they evolved over time. So both are created from your Sentinel Lake. Both enable you to be very flexible, to use iterative notebooks. And you can start small and evolve the model in time as you learn more data, as you learn what's useful for you. For any such graph, you can also have a set of heavily computed algorithms. One of them would be the blast radius, as we presented before, or path ranking, maybe K-hop traversals, and others. So getting practical, Sourin would lead us with a demo.
Thank you, Shirley. Let me quick switch over my screen. 1 second. Okay, thank you, Shirley. Again, hello, everyone. My name is Sourin Paul, and on behalf of the entire Sentinel Graph team and the team members here, I have the pleasure to show you the power of custom graphs in Sentinel. Now, your journey to build a Sentinel custom graph starts with identifying what security threats you want to address. Today, for example, you may have advanced machine learning detections, creating alerts for your SOC for any access anomalies from your environment. But a common challenge is to quickly determine which of these access patterns involve, let's say, unmanaged privilege escalations or associated with the potentially compromised users, or just simply the blast radius of a benign user with legitimate access to key resources. With Sentinel Lake, you now have the ability to bring all your PAM telemetry logs from any tools of your choice that you use in your operations, such as Okta Privilege Access, CyberArk, or BeyondTrust, in the lake, and combine them with enter user and activity data to create a potentially tailored exposure and a tag graph for identities. I mean, we alluded this with these examples in the 1P graph, but now you can do so with all your other data set. This enables you to quickly answer questions like, hey, what are my users commonly accessing using PAM? Are there any unmanaged users accessing crown jewels kind of resources, or blast radius of a potentially compromised users, and so on and so forth? So allow me to show you how you can go ahead and create these custom graphs today. All right, what you're looking at, and I will quickly switch over to the actual tool. What you're looking at is an experience in the Sentinel VS Code extension, wherein you can simply leverage the power of Sentinel Graph library to build graphs with any and all lake data. For example, if the switch happens, 1 second. What can see if this shows up. It's always fun doing a live demo, so bear with me. And there it is. Okay, so what we're looking at again is in the Sentinel VS Code experience itself, and this is a notebook running within the Sentinel experience. So simply speaking, section 1, make sure that you are authenticated and in the right environment, allows you access to what I earlier mentioned as Sentinel graph libraries that you can use to generate these graphs. So I'll glance over them. There's nothing much to see here. Section 2 allows you to combine all this lake telemetry and make sure you are able to query the data that is already there in the lake and make sure that you have the necessary telemetry to generate this graph scenario. Moving on to the most important section, section 3, this is where you start defining your graph ontology or what you want it to be. In this example, we have created 5 nodes representing the user and the various resources we think for this scenario the user could access, along with identifying the user activities or the ways the user could access these resources as relationships or edges in the graph. So you define all your nodes and edges using the library methods conveniently. Once you have defined the graph, we can build it using the same notebook. You build a graph with a simple command, and once the graph is ready, the fun begins. You can ask plain queries using GQL to answer the questions that we initially started to solve the problem with. For example, in this first query, we are looking at, hey, what resources and how did a user, for example, Jordan Spark, access in my environment? So I'm looking at all the resources that Jordan Spark has access in my environment, and how did it go? How is he going about accessing these resources? If I click out of it, you can play with all the edges that you have earlier defined. You can filter those edges. And again, all this with a simple query, you have brought in all the access pattern information from your telemetry logs from the lake. You can further dive in to say, okay, great. Show me, this is Jordan Parks or Jordan's access patterns, but show me what other resources have accessed this, any kind of critical resource. For example, let's say Cloud Azure resources or ARG resources in my environment, and who all have access this. So now this simple query, it's a 5-line query, kind of returns all other users who have accessed Azure resources in our environment using some form of a production vault. I can go ahead and expand to look all the users who have accessed this. I can look at the resources that were accessed. And by the way, this is all to answer the question, what is potentially bad in my environment, or when debugging or when triaging an alert, you are trying to answer the question of, is it really bad, right? This is relatively simple still, but we can go on. As you can imagine, great, these are all the other users, but how many of these users are really unmanaged? Should I really be worried about? What tells me that this is bad? So you could, from here, pivot and write some form of an unmanaged, some form of an hunting query to say, hey, are there unmanaged users who are accessing these resources with or without PEM? In this example, the query simply returns a list of users who have accessed resources without PEM. And because it's a list of users, it's in a tabular form, perfect for any form of analytics consumption or analytics use cases that you want to consume. Only showing you that visualization is one part of graph exploration, and these kind of analytics based out of graph queries is the second powerful part. So all this is still great. I'm asking questions, I'm getting answers. So what? What if I want to create attack paths or identify attack paths for exposure or attack vector kind of scenarios along with the identity? So there are multiple out of the box graph algorithms that we provide, which you can leverage on your custom graph, of course, if they're scenario applicable. One of them is a blast radius. So you can use a K-hop algorithm to kind of identify, hey, let me say a user called Alex Chen, what has he explored or what can he get to in my environment within 3 hops. So here I'm looking at Alex Chen's queries and what resource he is accessing, pre-configuring the fact that what resources he can get to within 3 hops. So this also presents, number one, an attack surface for a user called Alex Chen, who may be currently benign but potentially compromised, and how, if the user is compromised, can an attacker laterally move in my environment to access what Alex already have access to. So this is extremely powerful. You can further go and expand this and say, great, this still looks not like I want to go deeper and look at like, okay, this is 2 hops, but I want to further go and say the entire attack path. And we can do so for, this is an example of a different user who has access resources in multiple mechanics, and you can use the same K-hop algorithm, just increase the hop count to be able to show the entire attack path to understand what Jordan here has access to, what resources he can get to, and how does he get access to those resources using vaults or other mechanics or a service principal and so on and so forth, all in a single query. Right? So once you have built these graphs in your tenant, your team has access, of course, with access privileges controlled and so on and so forth. Your team can simply query this graph to answer all these evap questions that I've answered and consume this graph analytics and insights over time during triaging, in investigations, or any kind of remediation, incident remediation activities. So as you see, custom graphs in Microsoft Sentinel let you model attacks the way they actually happen in your environment by connecting identities, cloud resources, signals, devices, all into a single explorable graph. So let me summarize. In Microsoft Sentinel, in today's webinar, we saw how in Microsoft Sentinel, you can leverage the power of Sentinel 1P graphs built over Microsoft telemetry, how you can leverage the power of MCP and AI tools to interact with Sentinel graphs, and finally, how you can generate your own graph insights. And with that, if you want to move faster and look at how you can try some of these functionalities today, you should be able to sign up. Again, we shared this multiple times on the screen, but you should be able to sign up for all of these capabilities, try them out in preview with this link. Finally, thank you again for spending this time with us. Please add your questions to the chat, and we'll be happy to answer.
Thank you so much, Sourin. If you have any questions, please feel free to continue posting your questions to the live event Q&A. I will go ahead and read some that were submitted for our presenters and some of their helpers on the call to ask. Could you leave that slide up, please, Sourin? All right, so one of the questions that came in is, data lake queries are paid. Is using Sentinel Graph also generating cost? I think Steve was going to take this one.
Yeah. Basically, kind of what was written there is that so the Sentinel Graph provides the graph analytics experiences across Defender and Purview, as Shirley showed earlier. Things like the incident graph and hunting graph, data risk graph. Like all these graphs are there's no separate license or additional cost to turn on, to use, or to query. So you can use them as soon as your environment is onboarded to Sentinel Data Lake, and then you have the relevant security data is available. So no cost there. In addition, like the custom graph and graph MCP capabilities that were shown by Sourin and Shirley are in public preview, and so you guys can try that today. During the preview, customers can experiment with these capabilities without any graph-specific chargers. Just be in mind, like standard data lake ingestion costs and storage will still be applied, but during preview, the querying cost for the graph will not be charged. So, thank you. Anything else?
Thank you, Steve. I have another question that was submitted. It said, can you please explain those?
I think that Renee might be. I think Renee might be having issues, so I will continue reading the questions. Thank you, everybody. And we have another question. When is it more appropriate to use graph representation instead of standard KQL?
Good question. Does anybody want to take that, or should I? I don't want to hog the mic, but I'll go ahead and do that. So it's a good point. I think a lot of times we're familiar with KQL, and so a lot of our events and data that we do store in our SIEMs or security analytic tools are event-based. They're logs of entries of activities that happen within your digital environment. So when you do know what you're looking for, it's easier at times to use the KQL, because you can, let's say, search for a specific IP and join that to another, let's say, table of maybe network data or device information, EDR data. And so usually, and this is kind of my simple answer because we don't have a bunch of time, but like when you do know what you're looking for, specifically, KQL is a method that usually works. When you don't know what you're looking for, and it's a relationship between your entities, so things like users, devices, IP addresses, when you look at those things and you want to know how they're related, and you don't know exactly maybe what exactly yet you're looking for, but maybe it's more about the relationship than about like a specific one-to-one connection. That's where a graph is super powerful, because you really think about joining multiple tables together to really bridge together the meaning and the relationship between multiple entities, as we kind of mentioned in the beginning. Like there's a layers of technologies, right? Whether it's emails, identities, devices, network information, and chaining those together. A graph is super powerful in helping analysts and hunters to be able to visualize that, connect that, even query against that type of data. So hopefully that answers and in this short time. So thanks, Pablo.
Thank you very much for that answer. We have a couple of other questions. Can you please explain the skill set required to implement this? In my experience, this seems beyond most SOC teams' capabilities I have worked with.
Yeah, Yaniv, do you want to take that one, or maybe I'll kind of frame that? Well, Soren's about to come off mic, but I'll kind of frame that. Like, I think I want to take that question in two parts. So the question there, I'm assuming is more on what Sourin just shared there regarding customizing your graph. So maybe you have your own ontology. Maybe you have a unique data model that you want to build. And so there's that part of the question that I'll let Sourin answer. But the components that Shirley showed, it really kind of lends to how easy and built in the graphs are to be used and consumed by SOC analysts, tier 1 analysts, tier 2 analysts, threat hunters with the hunting graph. So those are all built in and out of the box and with predefined scenarios that, SOC analysts can use right away without having like a high bar, let's say, to consume that and start getting value out of those Defender and Purview graphs. And then I'll let Sourin maybe answer the question regarding like if you have your own ontology and your own graph that you want to build across, the custom graph scenario. So go ahead, Sourin.
Yeah, sure, Steve. I think to directly answer the question today, if you want to build a custom graph using the VS Code extension and a Python notebook, the bare minimum skills that you would need is Python. So as long as you understand Python, which is why we shipped and made available a graph library so that we can normalize the skill sets that are required to build this graph. So it's still, as long as you are comfortable understanding Python, and of course we have GitHub Copilot right now in VS Code, so you can always leverage those. The built-in library is completely published, so you can leverage that both in Copilot as well as if you're a good Python developer, it should not be any problem to build those graphs. Of course, our goal is to continue to make it more accessible to all personas within the security operation. So we're continuing to work towards alleviating any kind of skill requirements. That's our goal. But for now, Python is a good start.
Thank you very much for those answers. Next question is, would these features or experiences be available out of the box with existing licenses?
Existing licenses. So I'll take that one. So again, let me clarify what I think existing licenses mean. And again, I'll maybe talk through what those answers would look like. But again, I'll kind of over answer so it kind of covers any assumptions that I have, and hopefully it lands. So E5 licenses are typical like Microsoft security licenses that encompasses the security capabilities and compliance purview capabilities within Defender and Purview. So those graph experience that Shirley showed today are included. So you're entitled as an E5 customer. And so the capabilities that you would have to add on top of that is Sentinel Data Lake. And so there's storage cost, ingestion cost to bring over that data into the data lake. But in terms of the Defender incident graph, hunting graph, data risk graph experiences that you would use within Purview and Defender, those are all entitled. So hopefully that answers that question. And then, yeah. So hopefully that answers the licensing question. Again, assuming that that's what licenses they were talking about. Thank you for the question.
Thank you, Steve. Sorry, I think that you had something to add, or?
No, I think Steve covered it perfectly.
Perfect, thank you. Next question is, how to generate graph automatically?
So I can take a stab at this, and please, anybody feel free to chime in. So there are a couple of things we looked at today. One are the Sentinel 1P graphs within the Defender environment. You don't need to generate them. They're all already built for you. Once you enable them in your environment, or once you enable graph in your environment, not specifically a graph, they just become available as part of your existing functionality. No further actions are needed. I'm assuming you're not referring to MCP tools because you're referring to graph. And then the second part of graph generation we talked about today are these so-called custom graphs and graph analytics. Now, because they are custom, you would want to build them. I kind of quickly glanced through in the notebook itself where once you define the graph, you can say, hey, create the graph. Creating the graph itself is the enablement process right now. We'll obviously extend the workflow where you can create a graph and then in the future decide not to enable it and so on and so forth. But right now, creating a graph enables the graph and makes it available for queries to everybody in the SOC. There is no additional step. So those are the two kind of big pictures. If there is a follow-up there, please feel free to prompt and I'm happy to expand there.
Thank you very much, Sourin. Another question. No cost for the preview?
Yeah, isn't it surprising? Yes, there's a selfish reason behind this. We want you to try and provide us feedback and guidance on how well it works for your environment, where does it fall short, and we want to learn from it, and hence the whole preview. But we deeply believe that once you try it, you will be encouraged to include the power of graph analytics to expedite all your SOC operational activities and so on and so forth. And if you find value, then you'll continue to use it. So currently, yes, it's in preview.
Thank you very much for that answer, and it's great news for anybody that wants to participate in the public preview. As Sourin mentioned, we would like for you to participate, and most importantly, we would like your feedback. So give it a try, and I posted the link to the public preview in the Q&A section to one of the questions. Another question. Data lake queries are paid. Is using Sentinel Graph also generating cost?
Okay. I'll take that. So yeah, so I'll take that. So again, I feel like we answered that one, Pablo, now that I think about it.
Perfect.
Yeah, I think we answered that one.
Thank you. What is the difference between Graph API versus Sentinel Graph? Did we answer that one?
No, and I can take it if you're able to hear me.
We can hear you.
Okay, amazing. So Graph API, you all probably know it, came from our security like 2, 3, 4 years. It's an API that allows you to query specific security products like alerts, incident, user identity, and get answer immediately from our API in a live way. This is the Graph API. What we presented today is a new way to model your data that's already ingested into the Sentinel Lake and build ontology or ask questions on the data model with the nodes and the edges and the connection between them. So this is like totally different thing. I know that naming here in Microsoft can be a bit confusing. So totally different thing. One is an API. The other is a database, is a way to model the data that you can ask sophisticated questions and get some answers. Hopefully it was clear.
Thank you very much, Anil.
And I have a question. So I saw that Sourin in your graph, like VS Code, you open VS Code. I'm assuming that you installed the Sentinel extension there, and you run some queries against the graph. Can you elaborate more about like the language there? What is it? Was a KQL?
Sure. And so today we support a language called GQL, which is an extension and evolution of the OpenCipher and soon becoming an industry standard for all graph query languages. So graph query language itself stands for GQL, and that's the language we have adopted and we intend to support going forward as the graph industry itself evolves. So GQL, again, if you're familiar with Cypher, OpenCipher has been an evolution of that, is becoming an ISO standard, and that's the query you saw in those screenshots. So if just look up Google, there are references of GQL all over, but we are also happy to share references if you need. And we will, by the way, as you sign up in the preview, we provide you complete reference of how to use GQL if you have never come across them before.
Excellent, thank you. Yanif, you had something else to add?
No, just want to say like you, amazing answer. Thank you for.
Thank you. And I think that we have gone through all the questions from our participants. Any final words from our presenters?
Sure, I want to say thank you, everybody. Again, we are really excited. I hope you try it. We want to know how well it works and where it falls short. So please reach out as you try them. Our entire team, on behalf of entire Sentinel Graph team, I thank you again for spending the time with us.
Yeah, again, thank you so much for joining us, and please share your feedback.
Excellent. Thank you very much, Shirley and Sourin. And to our attendees, thank you very much for your participation. One last announcement in the chat. I'm about to publish the URL to our public Microsoft security community. If you want to learn more about this and other topics and other innovations in our products, feel free to check it out. And the link is going in a second. Perfect. Feel free to check out the information in our security community. And with that, again, thank you very much to our presenters here at Microsoft and to everybody who helped answering questions from our attendees. And thank you to our attendees for joining us. Your participation in this public preview will be super important for us. So give it a try and we look forward to your feedback. Thank you, everybody, and have a wonderful rest of your day. Goodbye.